This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make lightning protection easy. If your wind turbines are due for maintenance or repairs, install our Strike Tape Retrofit LPS upgrade at the same time. A Strike Tape installation is the quick, easy solution that provides a dramatic, long-lasting boost to the factory lightning protection system. Forward-thinking wind site owners install Strike Tape today to increase uptime tomorrow. Learn more in the show notes of today's podcast. Welcome back. I'm Dan Blewett.
I'm Alan Hall.
And I'm Rosemary Barnes.
And this is the Uptime Podcast, bringing you the latest in wind energy tech, news, and policy. Welcome back to the Uptime Wind Energy Podcast. I'm your co-host, Dan Blewett. On today's show, we've got a bunch of great topics. We'll talk about number one, Bill Gates pushing for a new nuclear power plant in Wyoming. We'll talk about the future of nuclear and why it's getting some pushback from the wind industry and others. We'll talk about Vestas and Maersk. Rosemary's going to come out. She's going to maul me about my pronunciation of this in a moment. Their container deal and what that means for transportation for them. We'll talk about a French couple who has won a lawsuit about their health in relation to a wind farm that was installed near their homes. We'll talk about the Dominion's explanation of their $10 billion price tag for their coastal Virginia wind project. There was a blade that fell off a wind turbine in Froya. Maybe I got that one right. Could be 0 for 2. We'll see my pronunciation tonight. We'll talk about NREL with their 3D printing approach for wind turbine blades. They've got some new thermoplastic stuff that they've just announced. Siemens Gamesa has produced their first green hydrogen from a project. And lastly, we'll talk about a drone attack on a power grid. This is certainly not going to be the last attack of its sort. And we've actually mentioned this recently about subsea cables and their potential vulnerabilities. So we'll kind of go back and full circle there and talk through this story a little bit. But before we get going, be sure to subscribe to Uptime Tech News, which you'll find in the show notes or description of today's podcast, as well as Rosemary's YouTube channel, which you'll also find in the description. And Alan, let's start with you. So we're going to push right here into nuclear. So obviously nuclear power has a bad rap because we get that, big emotional response from Chernobyl and just the disaster that it caused. But in reality, it's actually quite safe and it does not contribute to CO2 emissions. So Alan, take us through this Bill Gates situation. He's backing this experimental nuclear power plant in Wyoming, but not everyone is on board with this.
Right. And this is something that Gates and it sounds like Warren Buffett have been invested in for a number of years, trying to develop lower cost nuclear power, more modular, smaller plants that are more economical to build and to control. And there's a company called TerraPower, which has been doing all the legwork and infrastructure to design these new next generation of nuclear power plants. And a couple of years ago, sort of pre-COVID, they were planning on building plants in China so that the Chinese government would stop building coal plants. That was the goal, was to reduce the amount of CO2 emissions and the sulfur emissions into the air by helping the Chinese develop this more compact, more economical, and yet highly productive nuclear plants, basically to lower the CO2 emissions out in the world, because China is the leading emissions from CO2. So that was a game plan. And then COVID happened and the Trump administration happened, and there became a limitation on nuclear technology traveling to China. So that left all the investors sort of stuck. And so now they've come back around and found a site in Wyoming to build this, basically a demonstrator. It's really what it is, of a new next generation nuclear facility. And it's supposed to be safer. It's supposed to use the nuclear material more efficiently. And there's discussions about using existing waste material in this facility, so we can actually recycle some of the nuclear material we already have. That's the goal. And that seems like, to me, on the outside, like, all right, yeah, if Bill Gates and Warren Buffett wanted to spend some money to see if this concept works, great. Like, all right, try it, right? They're not building a ginormous plant. They're building something on a small scale. But the pushback in the renewable industry is overwhelming right now. It seems like it's way too much, and it sort of discredits the whole purpose of where some of the renewable industry is trying to get to, which is to reduce CO2 emissions. Nuclear reduces CO2 emissions. We can have discussions about how much nuclear costs and the power produced by nuclear. That's a valid discussion. But in terms of reducing CO2 emissions, Elon Musk has basically said the same thing, which is you have to include nuclear. If you don't include it, then you probably are not going to get to the gains that you want to fast enough. And so I think in the renewable side, on the sort of the wind and solar groups, like you should welcome the reduction in CO2 emissions that somebody else is trying something new, just like we have been doing in wind and what we've been doing in solar. We've been trying a lot of things that are new. It's okay. It's not a threat to the industry. It's not a threat to wind. It's not really a threat to solar. They can all play together. And I think it's just a little frustrating when we seem like we become irrational. Right. I think there's too much push on the negative side and saying Bill Gates is an evil guy and is trying to rule the world and blah, 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 blah. And nuclear power is not as efficient as wind power in terms of its cost per megawatt hour. Okay, those are discussions we can have. But if Bill Gates is putting his money into it, he's put a little bit of mine into it, by the way, because the government's supporting this. But if he's putting a lot of his money in it, then it's sort of his risk. And good. I think we need to get to that. We need to get to that next step. And Rosemary, if we had stopped developing wind turbines back in the 1970s, then we wouldn't have gotten anywhere. And we've limited nuclear to the 1970s. And if we look at nuclear 2020, it's going to look a lot different. So is there a potential opening here to at least look at it?
Yeah, I mean, I think I'm not so extreme as many renewable energy enthusiasts, in my opinion, on nuclear. I think, like Dan said at the start, the safety concerns, like when you look at the actual, number of deaths per megawatt hour produced, it's one of the very safest technologies overall. And I do think that it was a real shame that there was, such a really sudden withdrawal from nuclear from a lot of countries after Fukushima. So, yeah, I think that. I am anti-nuclear for Australia, not strongly, but just purely because we don't have any nuclear yet. And I think that it's a big distraction that allows people to not do any of the, real decarbonisation stuff that we could be doing in Australia, because we just perpetually have this argument about whether we should be doing nuclear or not. And I think that same sort of argument is why people get really frustrated with Bill Gates. I personally don't think that he has, my long-term view of the energy transition is very different to his. I think that he still seems to be like he has an idea that I would consider pretty old-fashioned, that we're waiting for a new technology to come to save us from climate change, whereas I think that we have the technologies that we need, and what we need to do is spend a lot of effort into rolling them out. But all that said, for me, the thing about nuclear is just an economic disagreement. Do the proponents of nuclear, and especially small modular nuclear, say that it's going to be much more economic than it has been in the past because, you're going to have more units, although not that. I mean, to call it small is a bit of a stretch, it's not like a 1 megawatt wind turbine or something. It's, they're still pretty big. You're still not going to have that many of them to be able to get like a lot of scale effects, in my opinion. So, you know what? I want to see less talk about whether this could be cheaper in the future and more like testing out whether it will be. Bill Gates thinks nuclear is the answer and it can be more economic, and he's got the financial means to try it out. And that's exactly what we need. Try it, see if your assumptions are right, and try it as soon as possible so that, you know early on whether we should pursue this path or not. But I've got no problem with private money being used for that. I think it's just what people get upset about. And what I would get upset about is if we say we're going to do nuclear instead of wind and solar and batteries and everything. And I don't get the impression that that's what's happening here. So I'm all for trying it out, seeing how the economics goes.
Well, and of course, I feel like we all forget that there is nuclear power in the U.S. I mean, there's one down the street from Washington, D.C. in Louisa, Virginia. It's the Lake Anna nuclear generation plant, and they have 1.79 gigawatts. And I found this out because we went on a family vacation down there last year during COVID, swam in that super
To the power
warm,
plant.
creepy lake. Yeah, the lake is like 95 degrees. It's the most disturbingly warm water you've ever swum in. So, but yeah, that thing was built in 1978 and it's been kicking for almost 50 years now and seemingly perfectly safe, right? I mean, but when people hear about this in the news cycle, it still just has that cringy, that scary connotation.
But Dan, I think one of the things that we all need to consider here is, what are you going to take offline when nuclear is possible? You would take off all the carbon dioxide emitting power plants. That's what you would do. So if the goal is to reduce CO2 emissions, I think it has to be part of the equation, because wind and solar in the United States are not going to ever equal up the ability of the coal and natural gas and whatever else plants that we have here today. So if we shut all those plants down and we don't have anything to replace it with, the United States in particular will have a hard time operating. So we have to find something to fill those in. And Rosemary, go back to your point a little bit. It takes a lot of space to put the equivalent amount of wind turbines or solar in than it does to put a nuclear facility in. So if we're talking about real estate, I think that the footprint's a lot smaller than it would be for wind or solar. And the second is the recycling bit of it, which is always a problem for solar, is a big recycling problem, as we well know. The recycling thing we've kind of gotten figured out. You're going to store the waste, whatever waste is going to be generated by nuclear, on the same footprint space. It just stays there and possibly be reused again. I mean, the way technology is moving. So I have a really hard time saying there's no room for nuclear. I think in order to have a developing economy or a growing economy, you're going to need power. In order to get power, you're going to fire up oil-driven, gas-driven power plants, or you're going to have to move to something else. And it can't be, unless I'm wrong. I mean, I could be totally wrong on this. I don't think solar and wind are going to be able to fill that entire gap in some of these larger countries. Am I way off on that?
I think you're totally wrong on that, Alan. No, not totally wrong. I think solar and wind and other kinds of storage definitely can. Even 10, 20 years ago, we could have moved the world to a completely clean electricity system at just immense cost. And now that cost is a lot less. And in the future, we'll see it, move further. And then, you add nuclear, it certainly makes it a lot of a smaller transition, because nuclear much more closely mimics the types of generation that we've got now. We're used to base load with, a little bit of variable for peaking. So that would be easier, but how much will it cost? And I don't think anyone would argue that nuclear's cost reduction curve is going to be nearly as steep as, solar, wind and batteries, which are, have got great economies of scale, and they've been demonstrated to just exceed expectations for price reductions year after year after year. I don't think anyone thinks that nuclear is going to reduce as steeply. Whether it reduces, I don't think it's reduced at all. Actually, in recent history, I think price has actually gone up per megawatt hour because people are a lot more safety conscious and because there's a lot less being installed. So I'll accept that there's cost reduction potential. I don't know how much. I think if you leave nuclear out of the discussion, then you are, leaving out the possibility of finding the cheaper solution. And like I said before, I wouldn't shut down any nuclear power plants unless they were unsafe. I think Japan's reaction to their crisis is understandable, and I think every other country's is probably a bit of an overreaction. That's what I would personally do. But yeah, I would look to the future and say, you leave all options on the table and assess them on their economic benefits. To me, that's the way that we get the fastest transition, is by, letting technologies compete on cost, because, when it's about the economics, you don't have to get government saying, oh, we need to do this, 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 and this. You just kind of, let business people figure out how they're going to allocate the resources to get the fastest transition. So, yeah, I've got nothing against nuclear. I just suspect that it's not going to have the price reductions that its proponents say it will, and I'm really happy to be proven wrong by this project and others if that's the case.
Yeah, I think we don't know yet, and because in the United States we have essentially stopped all nuclear development since the 1970s, so we don't know how far it will go, and we need to do something new and to check out the technology to show it will or will not work. Because if they do create something that has a massive sort of scale and also reasonable energy prices, then I think it comes back into the discussion again. Because there are some places on this planet will be very hard to get wind or solar to be the main thrust. In Australia, different situation, right? And I think there's definitely a renewable future in front of Australia. I'm not sure everybody else is in that same boat. So I'm of the opinion, like, let Bill Gates go for a little while. Let's see how this plays out. Instead of killing the guy all the time, let it play out. And you may be right. You may be totally right. That Bill Gates has got money. He's not going to go hungry at night if this thing goes belly up. It won't bother him. But if it works, it could be beneficial for everybody. So I'm willing to let it play out.
I would love it if nuclear was something cheap we could roll out a lot. That would really and fast. That's the other thing, is that I think that it's not going to be so fast to restart a nuclear industry, even in the US where you have one already. That would be so much easier, technically speaking. But I just I'm skeptical. But it's put your money where your mouth is, and he is. Yeah.
Well, and just like solar, there's obviously environmental concerns of where you can put it. Not to mention not wanting to have it too close to major areas of people, but also the site in Virginia was found to have a risk of earthquake of only 1 in 22,000 each year. So obviously they don't want to put this, like, there's not a nuclear plant going in Louisiana, right? It's Hurricane Central. Yeah. Or in Kansas, where a tornado is going to run through it sooner or later. So just like solar or wind or anywhere else, it's only going to fit certain locales. Sounds like they did their diligence in Wyoming, and that's going to make sense out there. But yeah, we'll see. So moving on, Maersk and Vestas have signed a big deal, which essentially gives Vestas first crack and direct access to container capacity at a fixed price. And that's going to be where they can get parts shipped directly from their ports to manufacturers and warehouses, et cetera, which seems like it makes a lot of sense. Now, Rosemary, you're about to give me a clinic in how to pronounce Myersk as a lowly
You're
American.
Saying
so
it badly
please,
now.
no, I'm not. Well, I forgot. I'm trying to produce this podcast the best I can, and I'm overwhelmed. My internal memory of my brain. Trying to think 2 words ahead. I've lost it. So fill me in. Maersk, right?
Maersk, yeah, exactly.
That's better.
Yeah, perfect. That was great. Yeah, Maersk.
Okay, thanks. So Rosemary, what's your take here? Obviously, shipping, logistics, all that good stuff. We've talked about how raw materials are getting more uncertain in the future. It seems like Vestas just wants to lock down, like, hey, we want to make sure we know we have containers. We know we have the shipping logistics. In the distant future. Does this seem like a good move for them?
Yeah, I think so. I've been surprised actually at how much supply chain logistics is affecting everything, literally everything, not just renewable energy, not just wind, but anything at all. So I think a lot of companies have been surprised too. We've had this big push towards lean manufacturing, where you kind of just have everything just in time. You don't have big warehouses full of stuff, and I know that's starting to look less like a really good strategy for this year at least, and probably into the future. So yeah, it's tricky for companies to predict what the future is going to be, because if the problem just goes away quickly, then obviously Vestas will probably be overpaying for this extra security. But I guess it's about mitigating risks, because projects all over the world in any kind of industry are just seeing delay, cost increase. And so I think any business would be looking towards trying to reduce some of the risk of that getting worse in the future.
So moving on, there's a French couple who has been in a legal battle over a wind farm that said that it affected their health. turbine syndrome, which could include headaches, insomnia, irregularities of their heart, depression, dizziness, tinnitus, nausea. And they basically said that once some forestry or some is forestry? Forestry is forestry is a verb, right? Once some forest land was felled near them through the act of forestry, perhaps that sound barrier. See, we're all learning about language here today on Uptime. That sound barrier was removed, and they said this got significantly worse, where essentially their quote was that it was comparable to a washing machine continually turning. And of course, the reflection from the white blades obviously can cause shadows and reflecting light in general. So, Alan, they won their litigation. They were awarded more than £100,000 in compensation. And I guess the question is
euros.
Oh, euros. Got it. I'm learning a lot today. This is a great day for me. So, are we going to see more of these? Is this going to open the floodgates, or is this sort of a one-off kind of thing?
Well, I think France wants us to make this a one-off thing, but I don't see how you keep it one-off. Obviously, there's such a very unique situation in which they had a buffer of trees in between them and the wind turbines, and they are 700 meters. So I'll put that in American. It's about a half a mile away from the wind turbines. That's not really that close, but they felt some health effects from it, or they think they felt some health effects from it, and brought up a suit. And I don't think once you establish that precedent, it gets really hard to stop it. You can say all you want about it's not precedent, but it is precedent. And maybe there are unique situations about it, but those things tend to creep. And unless France comes in and prohibits lawsuits of this particular type, I don't know how you're going to stop it. We're going to see more lawsuits in the United States. We already have seen a lot of lawsuits in the United States, and we're trying to work around those things. I think the real key for engineers is that we can't put people underneath wind turbines, and we need to be considerate of where people live. And it doesn't happen very often, but it does happen. And I think if they would have left the trees as the buffer in between, they could have saved themselves €100,000. It seems like you could plant a lot of trees instead of paying out that kind of funds. So I'm just curious as to why they didn't choose that as a better option. And I know in the States, especially as we get, and Rosemary's going to see the same thing in Australia, when we start putting up a number of wind turbines, particularly offshore, we're going to have a ton of complaints about it. People about expensive offshore properties, and there's a flicker, right? Or my sunset has changed, or my sunrise has changed. And it's just going to be never ending. So unless there's something done legislatively, I don't see how it's going to stop.
They all sort of spiral on one another. So if you start to focus and fixate on the wind turbines and the noise, it'll never go away, right? And I mean, I lived in a different apartment early in the summer, and a nightclub moved beneath me. I was on the second floor, and their bass was pounding through the floorboards. And even as I tried to mitigate it, I eventually moved out because I couldn't. I mean, it was just like so intense. But even as I tried to, it was just so present in my brain, my irritation at the sound. It's like you're seeking the sound out. And at that point, it's like the problem is never going to be solved. So I can imagine if you're living near these turbines, you can't just like go about your merry way and be present in every other activity and just forget they exist. You're probably going to be so hyper focused on that sound that you hear it even when they're not even turning sometimes, right? That's how humans sort of are when you get disturbed.
I think there's two different issues here that kind of get conflated, because there's one about like noise, audible noise, and we already know that noise can be annoying, and all kinds of development have, noise limitations on them, especially, including wind turbines. And I know that that's something that we're very focused on in the industry. You do a lot of modeling before you make a new wind turbine to predict what the wind will be. And then if your modeling turns out to be wrong by a decibel or two, that can be a huge problem for certain cases. So the noise part of it, I think that's pretty well understood. You can also easily measure it, get an objective measurement of what the noise is, and there's a limit. Same for if they put a highway in near your house, there's limits to how much noise can be near houses. So that's understood. And totally reasonable and not that hard to deal with, not different to any other kind of engineering or construction project. But then the other side of it is this idea of wind turbine syndrome, which is supposedly related to infrasound, which is like low frequency noise, inaudible noise. So it's kind of funny to call it noise if you can't hear it. And infrasound is everywhere. It's in wind, it's in waves. You know, people live near the ocean and love the soothing sound of that. So that is, I don't even want to say contentious, because if you do a medical review of infrasound and wind turbine syndrome, you won't find any evidence that it harms humans. You'll find a lot of studies that have failed to find any link between infrasound levels and human health, but it's, you know, you can't prove a negative. So we just kind of keep on studying and studying. But if you're interested to learn more about it, there's this researcher, I think he's Australian, but I'm not sure, called Simon Chapman, and he's been kind of logging the symptoms that people associate with wind turbine syndrome. He has 247 listed in his book, and I'm just reading a quote in a paper that he wrote. These include lung cancer, skin cancer, hemorrhoids, gaining weight, losing weight, and my favourite, disoriented echidnas. That's a small Australian animal. It looks like a porcupine a little bit.
Disoriented echidnas. Wow.
Yeah, and then he goes on to say, but most.
Do you know why I know it? Do you know why I know what an echidna is?
Because it's an awesome animal.
Sonic the Hedgehog had a sidekick who was an echidna. That was like the game of my childhood.
Really?
Sonic, yep. I can't remember
Sonic
what his name was, but it was like maybe like a couple iterations down the road. Sonic and Knuckles, I think was his name. Sonic and Knuckles. Knuckles the echidna.
Well, fun fact, echidnas are mammals, but they also lay eggs. So
weird.
Doesn't that violate the law of mammals? Okay.
They also collect rings at high speed with blue hedgehogs. So
yeah. So anyway, Simon Chapman goes on to say that most of the symptoms are classic symptoms of anxiety, things that can happen to you when you're very worried. And then that ties into what you were saying, Dan, where these, like, I don't think that people who have wind turbine syndrome are making up their symptoms. It's just, I think that they're misattributed. And so Simon Chapman did a lot of research into why people get wind turbine syndrome and where, and it's, you know, very clustered in English speaking countries. When I moved to Denmark, no one had even heard of it there, which was, you know, lovely for me because I had been quite sick of hearing about it all the time in Australia. And anyway, he found that it really follows where certain groups of people went to protest wind farms before they were even built. Where those protesting groups had gone, people got wind turbine syndrome, and where they hadn't, they didn't. So it was like, you know, building up this expectation of negative things happening. And then the symptoms are all very, very common symptoms. Like everyone has headaches sometimes and sometimes has trouble sleeping. When you're looking out for these things that might happen, it's very easy to, get in the cycle of, oh, you know, all these terrible things are happening to me. You get anxious and then you get more symptoms from the anxiety. And so I think it's a real problem, but the cause isn't from infrasound from wind farms. It's more of a social thing. And what I've learned from the whole wind turbine syndrome thing is that it's not enough to just, you know, look at the technical facts that infrasound does not make people sick directly, because actually it's important to know how the community is going to react to things and bring them on board. And I think a lot of the wind industry were really surprised by wind turbine syndrome, dismissed it for a long time because it seems really ridiculous to a very technically minded person. But it's a real problem. It's just not an engineering problem. And so it's one of the things that I really like about, you know, communication like this and my YouTube channel is you get feedback from non-engineers, non-industry professionals about what they're actually concerned and optimistic about with the energy transition. And I, ever since this whole wind turbine syndrome, it was quite a big thing in Australia, I've never really dismissed those community concerns. It's not only about the technology, that's for sure.
Yeah, well, and of course, as we talk about them cutting down the forest, and it's not clear that the wind turbine company cut down the woodlands, but if you start thinking of like other mitigation strategies, like obviously like in roads, they put a huge sound barrier between a highway and a community, right? If there's a suburb right next to it. And so you think, oh, well, they could do this. Well, it's like, well, it was certainly going to cost more than 100,000 euros to make a huge wall right next to this couple's land. So it's kind of just like, just pay the settlement and they moved away, and that makes more sense. So, when you have these big projects, sometimes it just makes more sense to settle out of court and pay them off, and it's cheaper than changing the project or the barriers that they might need to put in place. So moving on, speaking of big projects, Dominion, they've gotten a lot of questions about why the estimated cost of the coastal Virginia offshore wind farm is increasing to $10 billion, and why the levelized cost of energy for that project is now close to $90 at about 87 is the current projection per megawatt hour. So, Alan, you've been pretty dug in with all the news on what the Biden administration is doing, both good and bad, as far as trying to get wind stood up here in the U.S. offshore. What's your take here on this increasing project by Dominion?
Well, it sounds like the Biden administration is just going to send them a check to offset the increased cost due to inflation. And I'm not sure that's a smart move, because pouring more money into an inflationary situation causes more inflation. So I'm not sure that got vetted by any economists. Obviously, if I'm Dominion, I'm thinking that's great, because the cost, I can help keep the cost of the project down. It's not money coming out of my pocket. Obviously, Dominion is really trying to make this project go, and they're very aggressive about it. And Siemens Gamesa is participating in building a blade factory in Virginia to support it. So there's going to be a lot of great things happening around it. I guess the question is, economically, and this is where wind turbines and a lot of renewable industry can get in a pinch, if we get into some sort of economic turmoil, and in particular with rising inflation to really unrecognizable levels, then can we make some of these renewable projects work? And I think that's a really big drawback to what is happening now in the U.S. economy, and the world economy is feeling some of the same effects. Is rising inflation is going to really drag down the middle class. It's going to really drag down the lower class of people that can't afford these things. But it's also going to push up projects that we probably need to get done. And again, who pays the rates? It's the average Joe citizen is going to pay the rates for this. And so the cost of the project does matter. And I just think right now, the biggest thing to help the renewable industry is to control inflation, slow this unfettered inflationary growth down. I'm not sure pouring another $1.5 trillion into the economy is going to do that. And on these offshore projects, which I think need to get done, we need to have price stability. That is the one thing that'll really kill a project and will kill large corporations who have very slim margins, or this unestimated, unpredictable inflation. And until we get that done, this project that Dominion has is going to continue to grow in cost. $10 billion is going to turn to $11 billion, which is going to turn to 12. And we really can't have that happen at this point.
I was just doing some research on levelized cost of energy. I'm making a video on it at the moment. It's such a, obviously exciting topic. I've got a friend who he's an accountant, and he has a website where you can kind of put in cost assumptions, and then it will, tell you the result. So he's made a levelized cost of energy calculator for me on his like key numbers. And I was really surprised at how much the cost of capital really affects things. And it has got an interesting effect on the energy transition as well, because at the moment, the cost of capital for renewables is usually cheaper than it is for fossil fuel projects, because banks see it as quite risky that, like a fossil fuel, a coal power plant has a lifetime of like 40 years, and banks aren't sure that in 40 years it's still going to be, making the profits that they expect. So the cost of capital for coal especially, but some other fossil fuels, is higher than it is for renewables, just because of the perceived risk difference. And that's actually like a big thing in favor of of renewables. It makes it much more favorable and has a huge impact on the levelized cost of electricity. So yeah, it's I think you're definitely right that the inflationary environment is increasing costs by a lot. But that said, I did look up so it's $87 per megawatt hour expected LCOE now for offshore wind. And I know that LASA just put out their latest LCOE ranges for, they do it for all the different technologies. And the average for offshore wind is $83 per megawatt hour. So it's not like way, way, way over the top. I wouldn't like look at that figure and say, wow, this is a project that's been mismanaged or anything like that. It's probably, more just in line with, the kind of headwinds that any kind of capital intensive project's facing at the moment.
Yeah, in this particular project, they've said that the levelized cost of energy is between $80 and $90. That's where they set those two fence posts at, and it was at 87, right? And so the Biden administration says they're going to pour cash in it because they're going to drive it closer to 80. Without that cash, I think it was going to exceed 90, and it still may exceed 90. By the way, we're still 4 or 5 years off on this thing. We really don't know until it gets into action. But I think that can be really catastrophic in terms of the like you said, the investments that go into this, the ability to return a profit really makes the landscape much scarier. And this is why we see companies like Siemens Gamesa and Vestas and GE all being very hesitant to go after some of these offshore projects because inflation is trouble.
So moving on, let's talk about appears to be maybe a lightning strike. There was a wind turbine blade that has fallen off of a turbine in Frøya. And Rosemary, I'm going to need you to pronunciation check
Well, it's
me.
Norwegian, so I'm going to say it's probably like Frøya, because they're kind of quite lyrical in their accent there.
Okay, what she said. But these turbines are owned and operated by Vestas, and they said that lightning was registered there on Wednesday. Alan, again, what is the failure mode when a blade falls off after a lightning strike? Because, I mean, most of these strikes are to the tip. I don't see how the two really connect.
It depends on what kind of blade that it is. I think the blades that have had lightning issues, and this is not Vestas specific, by the way, so generically speaking, blades that have had lightning issues where the blade has come off have carbon fiber spars or structures internal. And if you're going to have lightning take out a blade like that, it has to damage a major structural component really close to the hub. And lightning can do that because carbon is conductive and lightning likes to follow it. And even if you try to prevent it from getting into the carbon, it's going to get to the carbon. If you had some uncontrolled event where there's energy entering into the carbon, particularly closest to the hub, I think the fatigue will eventually get to the structure and it'll fail. The blade will break off. And so these events were not really common with fiberglass blades. I don't remember pure fiberglass blades breaking off like that unless it was some real manufacturing issue. But with blades with carbon fiber, we're having a little bit of different reaction here that we as an industry, it's not particular to an OEM, that we as an industry do not quite got a handle on. And the one thing I point to, and I try to explain to potential customers of ours and people that are interested in lightning, is that lightning varies a lot across the world. There's different kinds of lightning. There's different sort of the amount of energy, the amount of current, the way they perform, the way they react. It varies based on where you are. And we as the lightning community, and I'm a part of this mess, I think, is that when you try to describe the lightning world, you try to put some envelopes around it. Well, sometimes you don't do a very good job of that. You don't think about that, how that could impact a design. And I think we're into that phase right now, is trying to figure out, like, what the heck is going on where lightning is catastrophically failing blades, because we got to fix it. And I saw some comments on LinkedIn. I'm glad you brought this up, actually, because I saw some comments on LinkedIn over the last couple of weeks, which said the industry group that defines the IEC spec is starting to get together, and they may produce an update in the next couple of years. Like, come on. Are we really going to take that long? Because the problem is that we're going to build a whole bunch of wind turbines offshore in the United States and everywhere else in the world. Do we really? And they're all going to have carbon fiber in them. They have to, because they're like 100-meter blades. You have to have some level of carbon in them. have we really got this lightning thing figured out? Yes or no? And we better get it figured out before we put a couple hundred turbines off the coast of, Virginia or Maryland or wherever, and then find out we have this massive problem. That would be bad. So there's just like this little pocket of lightning knowledge that's just not well understood yet, and we need to get it figured out like now, really fast now, because the results on a 15 megawatt turbine are going to be really bad versus a 6 megawatt or 2 megawatt. That's my take on this. So, hopefully there wasn't a lightning failure. That's the hope up in Norway. But if it is, then we need to be doing something about it. More than just fixing the blade. We need to get to the root cause of what's driving these weird lightning reactions.
Root cause. It's a good time for a blade pun. Anyone? Okay, we'll move on and leave that one teed up. So the National Renewable Energy Laboratory just announced that they've 3D printed a 13 meter turbine blade from recyclable resin. So Rosemary, you're our resident blade design expert. What stands out? Obviously, we've talked about thermoplastic blades a bunch in the last 6 months or so, but this was one of the first pieces they have to show for it. What sticks out as important about this news story?
That it's actual doing rather than on paper design. The whole time that I've been working with composites, which is well over a decade, people have been talking about thermoplastic wind turbine blades and making designs. I know in my PhD research, I started a study that's at least 10 years old that is a full-length wind turbine blade design out of thermoplastic. I can't remember how long it was, like 60, 80 meters, something like that. There's no problem. You've always been able to design it. I've got no doubt that it would work. The reason that they're not made is because they end up more expensive because, basically the properties, structural properties haven't been there in the past. And, I don't know if they are now. Some people say that they've found thermoplastic resins that are as good as thermosets, and I haven't seen the evidence of that yet. But the point is that when you use a material that's less strong and specifically less stiff for its weight, then you end up needing a heavier blade to get the same structural properties. They need to be stiff enough to not hit the tower under heavy winds and strong enough to not break, in that 1 in 100-year storm. And that's the extent of it. It's not that it's not technically possible. It's that it's not economically viable to make blades like this. So now we've got, some people actually making a 13-meter blade. So, it's obviously not close to full scale. On the one hand, it's progress because, we're actually doing and finding out, the issues that happen from physically doing something rather than just talking about it. But on the other hand, I didn't feel like a huge leap of anything really in the reporting because I don't think anyone would have doubted 10 years ago that you could print a 3D, or maybe the 3D printing part of it wouldn't have been possible 10 years ago. But, there's nothing that really surprises me about this being possible. It's just a matter of actually doing it.
Well, what happens next? So say they print 3 of these and they look great. Is there a turbine to put them on? Like, do they go in, does the CFO take it home and puts it in his backyard? Like, where does it go?
I don't know. Again, it's the economics, until you can make a blade for a turbine that someone wants to buy in this way, then it won't change anything. And so I'm kind of on the fence because, on the one hand, we're actually, doing stuff and progressing towards it. But on the other hand, are we going to take turbine sizes back to, 13-meter long blades just so that we can have the blades be recyclable? I don't think so.
Well, what about distributed wind? I mean, there's still some smaller models, and of course, distributed wind has not hit its stride and really taken off, and it could in different parts of the U.S. But I mean, do you feel like that could be an avenue? If you start at 13 meters, they can slowly tick up to where that's going to make sense on one of their turbines?
I mean, it's there's a place for distributed wind, but it's not the same. It's not the same thing that these multi-megawatt turbines are doing, and they never will be. And there's, like laws of physics that can tell you why they never will be. It's not just a matter of, we need to, make more of them and have costs come down. It's just, it will take a lot to go into now, but distributed wind is never going to replace big wind, even if it might be a good complement, assuming that you want small wind turbines everywhere. I don't know. I don't think it's such a big step currently, but I am happy that so many people are taking this issue seriously, and I think we will see progress, but I think we haven't seen it yet.
Well, I'm going to keep you on the hook, Rosemary, as we pivot to Siemens Gamesa. They had a green hydrogen pilot project, and they have produced their first green hydrogen, just like this friendly little turbine blade. That tap is now flowing. So, it's a Siemens Gamesa 3.0 111 DD. So that means 113 meter blades. And this project is obviously in Denmark, where, they're sort of at the forefront of all this. So, do you see these combination plants where they've got the green hydrogen production on site with the turbine? Do you see that going somewhere now that this is off and running, or is this still really early phase?
Well, I see this is a more exciting project to me that represents real progress. So I personally don't see it working out like that for green hydrogen in wind turbines, especially not offshore, because maintenance is such a big thing for offshore, and in general, anything you can take and do onshore instead of offshore, you would. So this seems like moving something offshore that doesn't really need to be there. But there are several legitimate technical advantages that you can have by putting it there. So, you'll save some losses, some conversion losses if you just directly power the electrolyzer and nothing in between the rotor and the electrolyzer. You don't need all the cables and transformers and stuff. So that's a benefit. I know that there's also some different sizing optimization that you might do. You might choose a larger generator, for example, than you would if you needed to get the power, the electricity onshore via cable. There's quite a lot of seemingly significant but not that huge effects that all come into play. And so that's for the wind turbine electrolyzer thing. And then there's just the idea that we're going to be using electrolyzers to help balance variable electricity generation, which I've always thought is just crazy. It's never going to work out like that because excuse me, because, electrolyzers are very, they cost a lot. So you want to be using it all the time. I just can't imagine anyone buying a really expensive electrolyzer and saying, yeah, we'll use it, 30% of the time. And I did notice in this project that they're starting to talk about putting batteries in there so that they can, get a higher capacity factor for their electrolyzer. And I'm seeing that in other hydrogen projects as well. So it's kind of none of the technologies are early at all. We've had electrolyzers for a long time. We've had wind turbines for a long time. But this way that we want to use them now is really new. There's all these different factors. It's a bit complex to kind of know exactly how it's going to work out. And so I do think we need projects like this to just see, okay, how does this end up working and what's the most economic way to run something like this? And I really feel glad that we're starting to see action on hydrogen now instead of just, the last 2-3 years, there's been so much talk about the possibilities and announcements of, billions and billions and billions of dollars being spent. But there's been no progress towards, actually figuring out some of those technical challenges that need to be solved, to see this huge hydrogen economy that everyone imagines. So I'm really glad that now this year we are finally starting to see people actually build physical projects, figure out what are the problems going to be, what's the economic impact going to be. We'll be able to make a plan for the future much better once, we've got a few more of these, some more actual experienced operation of these kinds of systems. Because it's one thing to have mature technologies, but when you're using them in a totally new way, it's not that mature. So, really really excited to see projects starting.
The green hydrogen thing, I'm not sure how this is really going to play out. I think there's definitely applications for it, like probably in the mining industry in Australia, actually, that it may make sense to do that to reduce CO2 emissions overall. And there's places in the United States that it could be very useful. It's just really getting the technology put together. Like Rosemary is saying, it's more of a technology thing than anything else. And I think the battery aspect is a really important part of this too. Like if you're producing energy and you're having an electrolyzer, you want to keep the electrolyzer running, you need to have some sort of energy buffer in the middle of this. And I think that's the missing link right now. And in fact, I was looking at the sort of battery storage companies this morning, trying to figure out like what's going on there, because that's, to me, is the missing link. Like inexpensive battery storage is the missing link. It helps both sides. It helps the green hydrogen thing, and it helps on the renewable energy side. So I looked up Form Energy's stock price, because stock prices are indicative of where the investors think the company's going to be 6 months, a year from now. And their stock price is down, like down enough where it's a little worrisome, because of the I thought after the announcement earlier in the spring that they would be skyrocketing up in value with all the names and associations with Tesla and all the technology people there, because that's the missing link. But the industry and the investors are not super excited about it. That's worrisome to me. So there must be something that I don't see, either a cost or a technology limitation or a size limitation or some regulatory hurdle that I haven't put my finger on yet, where no one's excited about it. And it may have a lot to do with inflation, honestly. It may be saying like, well, inflationary prices are going to be so crazy that renewables are going to be hard to do, and we're going to be stuck with some oil burning, natural gas burning factories for the time being, and everything gets shoved to the right. I'm not sure that makes sense right now. So, Rosemary, I think you're totally right. I think there's definitely applications for green hydrogen, but we got to get the energy storage piece in the middle of it, and that's not there yet. And that's the worrisome part.
It's kind of funny, though, because a lot of the hydrogen hype was about its ability to be energy storage. And that's one of the aspects that I've always been the most skeptical about, because I just couldn't imagine the business case. And now we're seeing, I mean, it's why it's such a fun field to be involved in at this time, right? Because you don't really know precisely how things are going to work together. But, what seemed like 6 months ago, batteries versus hydrogen, now it seems more like batteries plus hydrogen versus, fossil fuels or whatever. So I find it really interesting to see how things are evolving and changing. And, the more unpredictable it is, the more exciting it is, I guess, for an energy geek to follow.
Well, let me throw this at you. So the discussion in the United States 10 years ago was about using nuclear energy, nighttime nuclear energy, to create things like hydrogen. Is that off the table still?
No, I think people are still talking about that. Because so nuclear, it's big benefit is that it's base load, but on the other hand, we don't actually use energy in that way. Like it's a solid band. So it's like its plus side is also its negative when taken to extremes. So I definitely still see nuclear proponents talking that up, but it relies on it being the cheapest form of energy, I guess. And again, if you're trying to make hydrogen to match what your energy system is otherwise doing, then you're not. Like, I just can't imagine someone with a hydrogen electrolyzer, they're making a very valuable product, hydrogen. They're not just going to make that when the energy is cheap. They're going to make it whenever the electricity price is just below whatever threshold it is that allows them to make a profit on their hydrogen. So, of course, they're going to be using that as much as they can. So I've never really thought that it was such a suitable technology for energy balancing when the energy cost is such a is not the biggest component. The capital cost is really important for an electrolyzer. So to me, it makes more sense that other industries that are really much more based around electricity prices, they would be the ones that would be, really ramping up and down depending on the price. But it's we haven't seen heaps of that yet.
So last on our lineup today is an interesting story about the power grid in general and the stability of it. And the story from Wired reports that a DJI drone piloted by a still unknown, this man or woman was not caught, approached a Pennsylvania power substation with essentially two ropes hanging down with a thick copper wire between them. So if you can imagine like a U-shaped thing hanging from the drone. And I guess the goal was what they were saying, the Department of Homeland Security and the FBI said basically that the goal was to get over top of something, lower this down, then the wire touches and create a short circuit and disrupt the power supply that way. So obviously we talked a little bit, partly in jest, about, a supervillain disrupting subsea cables. But the reality is that if a country wants to, do acts of terrorism, trying to disrupt operations in any other country, they can certainly do it. And there's a lot of technology in place, including drones, which are very difficult to detect. They have not found this person because the operator of this drone stripped the camera off, the memory card, and any other identifiable markings. So if you know how to use one of these and how to kind of clean it up, they might not be able to track you very well. Alan, does this seem like this is going to be something that maybe Congress or other governmental bodies are going to need to probably get ahead of now that there's been one of these officially registered on the board in the U.S.?
I think the power industry has been aware of it for a number of years, and I think quietly behind the scenes they're trying to address it and find ways to deal with it. As we well know, if you want to cripple a nation, turn off its power. We've seen that in some regional conflicts. If you remember during the Iraqi invasion of Kuwait, that was one of the things that happened. I think on the way out, they just started blowing up all of the power lines and basically taking the country offline. And that's the way to do it. And Dan, actually near you, not many years ago, you remember there was an aerostat, which is kind of a blimp with a long rope on it, had cut loose. So there's an aerostat blimp sitting over sort of Baltimore, Washington, D.C., looking for incoming missiles that are headed towards Washington, D.C. And so it's an early detection thing. And it had come loose on its moorings. It started floating across up to Pennsylvania. And of course, what does it do? It drops this very conductive cable across these huge power lines and causes massive power failures on the way until it finally crashed. And so the industry is very aware of sort of air attacks on power lines. I think the question is, what are you going to do about it? And if someone really, really, really wants to get it done, I think there's not a lot you're going to be able to do besides try to quickly repair it and get it back in service again. We have all kinds. Well, Dan, as you well know, we have limitations on where drones can fly. In fact, you can't fly a DJI drone in the area of Washington, D.C. It just won't fly there. I'm curious as to see if they've actually applied that to other high-risk areas like power lines, because you could do that. Obviously, if you have malicious intent, you could bypass that, but still. Yeah,
because that's basically if you're taking like an off-the-shelf drone that has GPS software in it, all that stuff, it's not going to be activated. But yeah, if you're savvy enough to want to do something terrible like this, you're going to know how to disable that kind of stuff, and it's going to be sort of like a manual drone, not subject to DJI being able to control it like that. Yeah.
Right. Yeah, but I think as we go forward, Rosemary, don't you think that we're going to have a lot of cameras and systems to monitor the power lines, especially those critical routes like that feed New York City or that are feed San Francisco or Houston or Adelaide or Perth, that somebody's going to have some sort of system watching what's going on to make sure that you don't have an attack like that?
Yeah, probably. And I'm probably more worried about cyber security, more so than these physical attacks. But it does remind me of, I was listening to, I can't remember which one. I was listening to some podcast recently, with a woman who worked for the California, grid in some capacity. And she was talking about, the reliability of their system. And, she mentioned that when there's like a high bushfire or forest fire, whatever you call them over there, when there's a high risk for that and it's windy, then they will like preemptively shut down certain parts of the grid to avoid the power lines blowing over and causing a bushfire. And she said, people get like really annoyed about that because they have these blackouts all the time for something that, didn't even happen. It was just a risk. And she was saying how one of the things that they're doing to counteract that is getting more like grids able to operate as an island for a period of time. So it works in combination with distributed energy. So, if you've got some wind and solar, or even rooftop solar, in combination with household and community batteries, then as long as you've got the grid set up right, then you can operate in island mode. So it doesn't matter if you're disconnected, and that sort of work will make the whole grid a lot more reliable, and it would also work if there was an attack like this. So I think that it is just like part of the move from this like centralized to distributed energy grid that we're moving towards, and there's benefits other than cleaning up the atmosphere. There are also security benefits when it's done right. So I think it's really interesting to see what they're doing in California, and probably we'll see that sort of thing rolled out not just in bushfire prone areas, but everywhere. It just helps with reliability.
Well, and obviously, Alan, we've had radar technology forever, right? So it can't be that hard to have some sort of, radar detection system in a substation or whatever, where it's just like we can monitor and I'm sure figure out what's a bird and what's a drone. The movement patterns, I'm sure, are quite different, right? Yeah. Is that something that's probably going to just end up being like standard security installation in some of these things going forward?
Well, I'm still surprised that you're allowed to walk up to high voltage lines right now. Like I can't walk onto an airport because there's a fence around it or some sort of barrier, natural barrier there. I can walk up to any high voltage tower that I want to in America and do dramatic things to it. And I think, what are you going to do? Put a fence around every tower? Probably not. I don't think that makes any sense, but I do think there's technology today that will help prevent some of these real catastrophic things from happening, because it will be bad. It'll be really bad.
All right, well, that's going to do it for this week's episode of Uptime. Thanks so much for listening. Be sure to subscribe wherever you listen on Spotify, iTunes, Stitcher, or YouTube. Be sure to subscribe in the show notes below to Uptime Tech News, which is our weekly newsletter to keep you updated on everything wind and renewable energy, and to Rosemary's YouTube channel, which she continues to pump out great content each week, including live streams sponsored by WeatherGuard. So thanks so much again for listening, and we'll see you here next week on Uptime. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.